Hello guys, welcome to the Techogenius Academy. So today we are here to discuss the next series of Linux system programming. So whatever we have done till now is we are covering the Linux device driver programming and the BeagleBone Black programming. So how we can do the setup and all. And now I just want to start a new series of system programming, so we can relate most of the things between the kernel level programming and the user space application programming. So let's get started. So the first concept which I just want to discuss with you is inter-process communication. Why? Because in most of the interview, companies will ask you relate the concept related to this. Why? Because in the real time world, we are using most of the mechanism, um, like this message queues, pipes, and all these things we are using. So, what will be our today's schedule? So, there'll be various IPC mechanisms, which is like pipe, named pipe. We can call it as a FIFO also, first in, first out, and message queues, shared memory. So, we'll try to cover most of the things in this session. And before going into this pipe, I just want to tell you what is IPC. Okay, so IPC is nothing but it's an inter-process communication which is used to communicate between multiple processes. Like just suppose like your one process is running and you are running another process. If you want to communicate between these two program or processes, so the IPC will come into the picture. Okay, so the first one is pipe. So what pipe actually is? So pipe is nothing but a unidirectional byte stream. It has two ends, means that the two processes are connected to each other. The writing process ls has its standard output joined to the right end of the pipe, and while the reading process has its standard output joined to the reading end of the pipe. So before going to this concept, I just want to tell you that to keep two things in your mind. One thing is like you just keep whatever that general water pipe is there, so just keep that in your mind. And the other one is we have just it's written here FD is nothing but a file descriptor. If you don't know, a file descriptor is just a small positive available integer which is used to do this read and write operations. So whenever the process is created, the process manager will create a folder called proc, in which there'll be a different PIDs. So you just need to check whatever your process PID is there. So just go into that folder, and in that FD is the folder in it, which one is link file is created just to communicate, just to read or write these operations and all. So the next thing is why pipe have a limited capacity. Like pipe is simply a buffer maintained in a kernel memory. So this buffer has a maximum capacity. Once a pipe is full, further writes to the pipe block until the reader removes some data from the pipe. Just suppose you just on the pipe, and the water is flowing through that, and from the other end you just block that. Okay, so now the pipe is full. After some time, now the pipe is full. So now if we'll not unblock it, we can't put more water into that pipe, right? Similarly here, if you are writing some data into that pipe, and you have not removed data from the other side, so further more data you can't write into that pipe. Okay, so just to have the better understanding, so let's try some code related to the pipe. Okay, so I'll just uh, create one directory Linux system programming, great, cd linux. In this I will create IPC. Okay, so before going into this coding and all, I just want to write one header file, because there'll be so many header files we are using. So each time we need to write, because in pipe, message queues, FIFO, shared memory and all. So we are using we will use this header file. Okay. So what I can do, I have written in the text editor. I'll just copy that. Great. So what are the header files that included? Hash include stdio.h, signal.h, sys/types.h, unistd.h, stdlib.h, string fcntl, sys/stat, sys/shm, sys/ipc, sys/sem. So in this header file, so when we'll go to this concept and all, I'll show you that what are the header files we are including, and which is already present in the header file. Okay, so first we will do this pipe. Okay, hash include header.h. Great. After that we'll start with main. I'll just create the array of 2 for the pipe, one return variable, and I will call the pipe function, pipe p. Okay, and we can display the error message true. It's nothing but whatever that pipe call will do, it will show the message. Yeah, great. So now here we will just print the numbers. Yeah. So now here we are using fork. So fork system call is basically used for creating a child process. Okay, so if you want to see, just go man fork. Yeah, so this function creates a new process. The return value is the 0 in the child, and the process ID number of the child is returned in the parent. Okay, so basically it will create the child process. Okay, um, we will go more into this coding of fork and all. So while we are going doing this concept, okay. So this will be your child. Okay, else, and this will be your parent. Okay, so now we'll just open a while loop, and we'll just declare a array, and here we will mention, just enter the string or some data, and we'll scanf this thing. Okay, and here we will write the data to the pipe. P of 1, which we have discussed earlier, strlen of 5 plus 1. Great. So we are closing the while loop. This is for main. Okay, so in child we just want to read this. So then we'll just create the while loop here. Character array printf before reading in the child, read p of 0 comma your buffer, your array, and the size. Printf after reading in child, percentage session your buffer. Okay, and just to sync up this, what I will do, I'll just mention one sleep here. Yeah. Yeah. So what we are doing, so we are just calling this pipe system call, and we have just declared the array, and in that fork system call we are creating a child process. So what first of all, parent will run, so we are entering the string, entering the data into that, and we are reading in the child. Okay, so what we will do, we'll just run this cc pipe dot c hyphen o pipe. Okay, some error is there. Okay, 1 second, I forgot to mention comma here. Yeah, great. So we'll just run the executable. Yeah, p of 0 equals to 3, p of 1 equals 4. So enter the data. Just suppose I'm writing Rajat. After reading in child, Rajat. So hello. So in this way we can communicate in pipe, unidirectional byte stream, any array you can put. Okay, great. So this is the concept of pipe. Okay, so we'll just go to our slide. So when the next question is, when read and write system call fails, So read system call will block the process if there is no data available in the pipe. That means if you want to read the data from the file which is just empty, so in that condition read system call will fail. And the write system call acts as a blocking system. It's like if you're putting data into the file where the pipe is full, so in that the write system call will fail. Means like the unidirectional byte stream is full and you're putting more data, so where this data will go, so it's just a blocking call. So few things you have to keep in your mind. So if the process is collected the data, so that data is deleted from the buffer, which is nothing but a pipe. Okay, so the process reading from the pipe closes its write descriptor for the pipe, so that when the other process completes its output and closes its write descriptor, the reader sees the end of the file. If the reading process doesn't close the right end of the pipe, the reader won't see the end of the file even it has read all the data from the pipe. So read would block. Similarly, when a process tries to write to a pipe for which no process has open a read descriptor, the kernel sends a sigpipe signal to the descriptor. So I just tried to write it in a much more simpler way so you can understand these things. Okay, so this is the concept of pipe. So next we will go to the FIFO, which is nothing but a named pipe. So in a named pipe, uh, why we are going, so there is some disadvantage in pipe. So pipe is only for the related process. It's like a unidirectional byte stream. What happen if there is some unrelated process? So for unrelated process we are using named pipe. So what are the functions involved in the FIFO? uh, mk FIFO, it's a named pipe. mk FIFO open, read and write call. So what we will do, we will just go to the man page of this. Yeah. So what mk FIFO will do, mk FIFO file is used for creating a FIFO file, and it's a special file which is just similar to the pipe, except that it is created in a different way. Instead of being an anonymous communication channel, so once you have created a FIFO special file in this way, any process can open it for reading or writing in the same way as an ordinary file. However, it has to open at both ends simultaneously before you can proceed to any input or output operation on it. Opening a FIFO for reading normally blocks until some other process open the same FIFO for writing and vice versa. Okay, so this is the call we are using mk FIFO constant character path name. We have to mention the path and the mode. Okay, so what are the header files which is used here? Systype and syststat.h. Okay, which we have included already in the our header file. And the open read write call, you already know about that. We have discussed in the pipe coding. So what we will do now, we will just write the code. Vi FIFO underscore one, okay, 1.c hash include header dot h and main int file descriptor. So we just want two file descriptor here. I have to create an array for this, simple one. So now what I will do, I will just create a FIFO. This will be my file 1. This is the path, this is the mode, p error, mk FIFO. Great. mk FIFO f2 comma 0 this mode p error mk FIFO fd equals 2. We'll just open this file. Permissions fd1 another printf pid equals to percentage d slash n get pid. Great. So now we'll do fork. This will be your child, else same thing, while one. So here we will read and here we will write. Okay, so what I will do, I will just change in this code. So here I'll write, here I'll enter the data. Earlier we are doing in a parent thing. Printf, enter the data. Scanf percentage s comma a right fd comma a comma str variant of a plus 1. Great. So here we will hit read because fd1. Why? Because we have to write another program also, another process which will communicate with this program. Okay, printf for different processes we just need to check the data. Okay, great. Okay, so we have written properly here. So now what we will do, we will write another program similar to this. So I'll just copy FIFO file to FIFO2.c. Great. Yeah. So here what I will change, yeah, if you remember in the previous program we are writing, see, writing to the fd and we are reading to the fd1. So now here we will read from fd. Okay, and So this is the only thing we need to change. Yeah, great. So what we will do now, we will just create the executable FIFO bun.c hyphen o FIFO1. Okay, somewhere is there. 1 second. 34. Yep. Great. FIFO 2.3. Yep. Great. CC FIFO 1.c hyphen o FIFO 1. Okay. P error. Yep. Sorry. Yep. Great. Same for the second file. So now what I will do, I'll just open another terminal. Just for the better understanding. So you can see the print here. Yeah. ls cd linux system programming ipc. Yep, ls. So I will just run FIFO1 here. Yeah, mk FIFO success PID 26413. Enter the data. FIFO2 file exists. Okay, great. So PID is 415. Okay, so I'm just entering the data from here. See, the data is present over there. Hello. So many congratulations to yourself if you are watching this. We have successfully communicate between the two processes. We are entering the data from the one FIFO file and from the one named pipe, and to the other end we are receiving that. Similarly, from the other file, from the second process, we are entering the data and we can receive from the first FIFO file. So in this way, you can communicate between the multiple processes or the two processes and all. So our next thing is message queues. Before that, why we are going to the message queues? So the disadvantage of the named pipe is when a process are communicating with the named pipe, both the processes are alive. Because we have seen in the man page that both the reading and writing process has to be alive. So there is no such mechanism that a process can send the data to which process if multiple processes are there. In this scenario, if any of the processes are not live, the communication between the process will not happen. So we need to go to the message queues, because in the message queues we can do this, because if we are sending the data, so if the another process is not there, it will put that message into the queue. So whenever that other process will open and try to retrieve the data, So whatever it's present in the queue, so we can retrieve the data from that queue. Okay, so this is for this first part. So we have discussed pipe and FIFO. In the next session, we will cover message queues and the shared memory. So if you like this video, please don't forget to like, share, and subscribe, because your subscription will matter here. So we'll try to upload more and more videos from our end. Thank you so much.